So we're supposed to use these graphs to determine the domain points where it's differentiable, where it's continuous but not differentiable, or neither continuous nor differentiable. Okay? So one thing our text talks about is that differentiability implies continuity. So in other words, if you can take a derivative at a point, then that point is also continuous. So put in another way, if you can find the instantaneous slope at a point, if you can find the tangent slope, then it's continuous at that point. Okay, so when we're looking for things to be differentiable, we're making sure the slopes from the left and the right are the same. So like take any point on this graph. The slope as you approach it from the left of this point I've chosen, look, getting infinitely close without touching from the left, the slope is 0. Coming from the right, the slope is 0. The tangent line slope is 0. So it's differentiable. Okay. So at all points in this function, it's differentiable. That means we can stop there because that first part I said that if it's differentiable, then it's continuous as well. So for all points, -2 to 3, using interval notation, it's differentiable. That's what we could say for this graph. Let's see. So where is it continuous but not differentiable? Since it's differentiable, that means it's going to be continuous. Okay. Well, we just determined that all points are differentiable, so that's why this is out. And neither continuous nor differentiable. There's no points where it's neither of these two qualities, right? Because we said it's differentiable everywhere. So it's differentiable everywhere for this function. Okay. So that one wasn't super interesting. That's going to be hard to learn what these are looking at. You'll probably have more success with what those are looking for in this next one. Okay. So the things you're looking for are things that where the graph all of a sudden changes directions. Okay, so like look down here at x equals -1. The slope from the left is -1. The slope from the right is +1. Those slopes don't match, so it's not differentiable at x equals -1. Okay, so it's differentiable here. You can take the derivative from the left and the right, no problem. So it's differentiable. So this one is differentiable on -2 to -1, but it is not differentiable at -1, so we need a parentheses there, because it's not differentiable at -1. It is continuous at -1. There's a dot there. You can plug in a value for x, and you'll get out a value for y. And although the book doesn't make a clear dot, that's a sudden switch in direction, so there is a dot there. So where is it continuous but not differentiable? We just found a spot, okay? There's a solid dot, which means the limit from the left and the right are the same as the exact value here. The limit as x approaches -1 is the same thing of f of -1. Excuse me, you both get 0 from those. So it's continuous, but not differentiable at x equals -1. Okay, and then these are all fine. It's differentiable from -1 to 3, so that means it's also continuous. So -1, so I'll use union, -1 to 3, and then I'll use a parentheses again, because look at 3, the slope approaching x, sorry, that's 3 on the y-axis, so it should be 0. I made a mistake there, okay? We're only talking about these locations on the x-axis. I put in 3 because I was looking at it, so big mistake there. Okay, so at x equals 0, we have a problem. As you approach 0 from the left, the slope looks like it's +3. As you approach 0 from the right, the slope is a negative. So it's not differentiable here at x equals 3. But it is also not continuous there, because look, there's an open dot and a closed circle down here. The limit as x approaches 0 from the left is 3. The limit as x approaches 0 from the right is 0, so they don't agree with one another. It's neither continuous nor differentiable at x equals 0. Okay, and then continuous, differentiable. So no problems here. There's no sudden switches. But right here we have a problem. It's not continuous at x equals 2. Okay? So for it to be differentiable, that's why it's one of the conditions. Differentiable, continuous, not differentiable. So if you're able to take a derivative, it needs to be continuous at that point. Okay? Because differentiability implies continuity. So the limit as x approaches 2. The y value is like 2.7. The exact value of f of 2 is like 1.2. So the limit and the exact value do not agree with each other. So it's neither continuous nor differentiable at x equals 2. I think, oh, here, I didn't do differentiability. There's more places where it's differentiable. It's differentiable between parentheses 0 to 2 union. This is a lot of intervals. I think what the book is going to do is it's just going to say it's differentiable everywhere except x equals -1, because we said it's continuous but not differentiable, at x equals 0 and at x equals 2. I think that's probably the more succinct way of putting it. Right? Because we said it's continuous, not differentiable at x equals -1. It's neither continuous nor differentiable at 0 and 2. So that's probably the easiest way of stating the answers to those questions.